Hello, YouTube. As I sit here and I'm working on day two, I sit here and start considering other alternatives for creating electricity. And as you can see here, I have a Delco alternator that I was planning to turn into a wind turbine. I actually have it connected right now to a 10 farad booster pack for a battery. Um, Basically, what it is it's a capacitor, and what it does is it stores energy similar to a battery. It just doesn't store very much of it. But the reason I want to put this in is similar to what I have for my wind turbine process. Is basically I want to run the wind turbine. I'm sorry. Run the generator or alternator to create a little internal generator that I can use to power up and work my devices. It's a little difficult to set up, but I figured out that there's a frequency line, there's a low voltage line that goes. This is designed for a car, so it's basically it has two receptacles that basically energize the field, and that field must be energized at all times to produce energy that runs electricity out of the alternator and back into what would be the battery. Now, I have the supercapacitor as a temporary storage because obviously to hook it up to the battery bank, I'd have to do a lot of modifying. So I'm going to charge the supercapacitor up to 12 volts and, uh, and basically run that experiment a little bit later on to see if I can make with this bike over here, this little bike, buying a belt and using the electrical by obvious. I'm gonna take those little circular things off that make you move your hand, but make a bike that has a belt that's connected to the alternator to spin up and be a alternative way of refilling my battery bank. Um, doesn't sound hard. It's just that because it's an alternator, it's not designed to be very efficient. So I'm thinking maybe later I'll try to change that out for a DC motor. Maybe take away a lot of the components like a switch and other things that would have to be in place for me to use the alternator to energize the field and then recharge. I'd have to be pedaling pretty fast, I'm assuming too. So, but anyway, I'm gonna look at that a little bit later on throughout this week, being that I have a vacation week. You guys gonna see how I play with that and how I. This is basically me at theory stage right now. I'm seeing what can happen. Um, my charge controller just turned this fan on, so I guess it's pulling a pretty good amperage. I'm pulling with the lights on in every room, somewhere around 9 amps right now. Uh, so 9 plus 23, I'm probably putting into the bank about 31 amps, 32 amps. Uh, a little bit later on, I'll plug in the freezer when I actually have a checklist. I'm gonna get ice for one. I have to get ice because the best thing to do is to help your freezer with staying cold. So I'm gonna get ice. I'm gonna layer the bottom of my freezer with ice. Get some jugs of water, put them down there so I have cool water to drink. I'm gonna, since the freezer has baskets, I'm gonna have my cheese and my meats and things like that up there. My dairy, some milk. Uh, I'm thinking yogurt, eggs, just cheap things that maybe spend $25-$30 on food for the week. Something sustainable that a guy without a job could live without. I mean, you could easily mow a yard or I don't know, uh, organize someone's house, pick up cans even, recycle aluminum. All those things can get you 20-30 bucks in a day. So I figure for a week that would be sufficient to provide a livelihood for one person that isn't trying to be in a job situation where they have to put in their social security number, or they're in a situation where it's just hard for them to find a job. Would they be able to sustain themselves? And in this situation, this would be easily done. You would get upset and tired of eating hot dogs and cheese sandwiches all the time, but you'd be able to do so for 6 months, 12 months, and save every penny that you get until you get enough money to either A, buy a new house, or B, just kind of sustain your gas going back and forth if you're far into the country, or D, plan D would be basically save all your money in a way that no one can get it. And when you are ready to move, hopefully have somewhere near $10,000, $20,000 saved up, and you wouldn't obviously be in a place that's disorganized, but you would have a way of making everything work. One experiment that I wanted to talk about that I was going to do today is running my iron and running the freezer at the same time. So I'm about to plug in the iron first. If you can tell, I have a little surge protector plugged in. It's already ready. I was talking about this last night, but we have what's called ghost amps that come out of or that go to your electrical devices that when you're on a budget for electricity, you look for. This can actually be very helpful in every other household because you don't realize how much energy you're wasting that's not ever even used. If you have 2 or 3 TVs in your house, you're pulling 200 watts an hour easy without even using the TVs. So if you guys go on vacation, if you take away, if you go and basically go to work, have a surge protector so that you can easily flip the switch on and off, to where you're not having to go without. I'm sorry, let me flip the switch off because I'm already turning the iron off. So that you can go without using up ghost amps that will drain away from your power needs for later on from your battery bank and from your solar. So anyway, the iron's plugged in. As you can see, to follow the wire, plugged in. It's off. No power going to it, and as you can see, my supercapacitors are slowly causing the amperes to go back up to where it was. What happened was basically I had the iron plugged in and I was pulling heavy load, I'm sure. Iron on a 12 volt line, even at 1100 watts, because it's going to pull somewhere around 80 amps. And anyway, I'm about to turn this on, and we're about to watch and see what happens. Run this first. Let's see what we have here. We're negative 30 amps. Which line is this? We're at 113 watt. Oh, I'm sorry, 113. We're at 1100 watts. I'm not sure if you can see that. 1100 watts currently. We're at negative 50 amps. Negative 52 amps. Negative 54 amps. It's climbing. Negative 58. Oh, I'm sorry, 56. Whew. 57. The amps are going to continue to climb as the supercapacitors are completely being discharged. Basically, the battery bank is having to compensate by giving more power to the supercapacitors to provide power. And the iron's at full heat, and I just heard the thermal switch turn itself off. And now we're instantly back to, we're not charging, we're charging. Awesome. That took about, I don't know, a minute to heat up completely. But as you can see, it was pulling somewhere around 80 amps. 80 amps to heat that iron up. And it took, I don't know, somewhere around a minute to heat it up. And it's going to continue to cycle to keep the heat up. But that is crazy. 80 amps on a 12 volt line. You would have to be ironing for an impressive meeting every time that you would iron, or you wouldn't want to leave that bad boy plugged in, obviously, because you'll be pulling a lot of electricity out of your grid. Last night in all, I pulled out 97 amps, and this thing pulls out 80 amps per hour. By the way, if you guys are ever trying to figure out how these gauges work, they pull out on an hourly basis. So basically, I'm pulling in about 20.8 amps per hour. If you guys have ever read coulombs or know what a coulomb is, or capacitance or anything like that, basically amp hours are a rating over, and they're rated always at hourly rates. So if you're looking at the fact that you're having 1100 watts is basically watts is watts is equal to amps times volts. So since amps is at an hourly rate, you can also consider watts the same way. If you have something plugged in for a full hour, 1100 watts per hour will produce 1100 watts in an hour. and it will drain that. And yes, it will have a load, the equivalent of that coming out when it's reading the amp hours. So I'm not sure if that confuses anybody. That, as you could hear and probably see, the iron has turned on and turned itself back off again. But basically, what I'm getting at is, um, if you ever look at your meter, your trimetric, or if you're looking at your watt meter, everything is based on an hourly basis. So, if you want to calculate how much energy you're going to pull out of your bank when you run your microwave to do some popcorn, let's say it was a 10-minute microwave, well, you're looking at 1/6 of the capacity for that 10 minutes. So, or 15 minutes, you'd be looking at a quarter of the capacity of what you're using. So, for instance, if your microwave is 1,000 watts and you want to microwave popcorn for 15 minutes, it's not going to happen. But 15 minutes. My equation is basically take your watt hours, multiply it times 1.10% for conversion, and efficiency. So basically, if you're using a 1,000 watt microwave, you're going to be somewhere around 1,100 watts total pulled out of the battery bank. 1,100 watts times 0.25 for 15 minutes of an hour, which is 60 minutes, which is 25%. 0.25, you would come in somewhere around 275 watts being used and being pulled out, and you can divide that by your voltage of your battery bank. If it's 12 volt, evenly divided it by the 13 or 12, just depending on where you're at on your state of charge. But I usually say 12. So 275 divided by 12 is going to give you somewhere around 14 amps pulled out of your battery bank. So if your battery bank is in series and parallel, obviously you want to consider it at the 12 volt string. How many amps do you have in that string of battery? So if I have a 215 amp hour 12 volt battery and I pull out 14 amps, I'm gonna come in somewhere near maybe 95% of my battery after pulling that quick charge. So every ounce is going to count. But one important thing to keep in mind is after that microwave is cycled off, it's continuing to power or pull power from it to run the battery, run the clock, run the timer, to basically, if you got a remote, basically to run the little sensor to read it. All these things pull ghost amps, and if you unplug these devices, you will not use as much electricity. And also,